In this lesson, we are going to cover topic 2.4, also known as key features of graphs. So, usually when you're talking about turning points, most of you don't know what they are, but they fall into two categories, global and local. So, global maximum is just the maximum of your total graph. So, if we draw a graph, something like this, then global maximum here means the maximum of your entire graph. In this case, if we're looking our graph from here to here, we can clearly see that our maximum is right here. And this is the global maximum. And the global minimum is something when we look at our whole graph and we see that in the whole function, this is the minimum spot in our function. And you can clearly see that this is somewhere here. However, local maximum and local minimum tend to get a bit more tricky. So, local maximum is simply a point when, if you look at the point and you take a bit to the left and a bit to the right, and you see that the points next to your point have a less y value. While this might sound a bit difficult, to put it into perspective, what I mean is that if your local maximum is somewhere here, then if you look to your right in your y value, you see that the y value has gone down. And if you look to your left, you can also see that the y value has gone down. And this is actually a very easy way to understand where your local maximums are. The difference between global maximum and local maximum is that there can be multiple local maximums. And you can have one here, as it's also, if you look to your right and left, the points are going down. And the global maximum, there can only be one, meaning that it has to be the biggest of the biggest. However, local maximums you can have all around in your key features as graphs. The local minimum, for instance, is, I'd say, quite same. Is if you look at the point and you see that next to the point that you have, the graph is growing. So as you can see here, you have your point here, and next to it, the point your graph is starting to grow. That means local minimum. And the same with local maximum. You can have multiple of these local minimums. However, the global minimum can only be one certain place. And I even have brought out a very good picture to demonstrate all of this. Your global maximum is in one place only, and it's in the maximum of your whole graph. Your global minimum is the minimum of a whole graph. However, you can have local minimums multiple, and local maximums also have multiple. And as you can see here, your local minimum is very easily identified because next to the graph there is growth. And your local maximum, you can see that the graph is going down on both sides, and local minimum up. Therefore, you can identify it. So, how to actually find these maximums and minimums with your TI-84? So today's example, let's state this: 3x cubed minus 3x squared plus x minus 4. So from the previous lessons, you know where to input your values. So you go to y1, put 3x cubed minus 3x squared plus x minus 4. And then you go to graph. And you can clearly see your graph from right here. And for the instance of this, let's also zoom in. Let's put our minimum to be minus 5. And this also to be 5. So we can clearly see our graph very greatly now. However, if you want to find the maximum and the minimums, you have to go to second and trace. And this brings out your menu once again. So if we want to look at the global maximum, we simply start from the left. We take our left and go to the right. And then it says guess, and you see that your maximum is right here. In some cases, your coordinates are limited. It's said that accept coordinates from -5 to 5, and then you simply go to window and you put -5 to 5, and these are the coordinates. Second trace, and you put minimum, and you take everything. You go to left bound. You always start from the left. You take this and you go here, and guess is not necessary, and you get your minimum to be this. And if it said that you have to, for instance, you only have to take into account coordinates from -2 to 2, then you can also kind of zoom in into your graph, and it said that you have to find the local maximum over here, and then you simply take into account these, and you can always find the maximum. So let's also talk about asymptotes. So usually a lot of people already know, but in preschool and also in your previous classes, you have most likely learned graphs as something like this. And these graphs are actually very common, and horizontal asymptotes, or asymptotes overall, are basically lines that your graph never touches. So usually, you know, when you have your graphs, they go very close to a number. However, they never reach it. So essentially, your horizontal asymptote is the horizontal line that your graph never touches. And horizontal asymptote is mostly labeled with the letter K, and it's very clear that you always have to say that the function is reaching to K, and K is your horizontal asymptote in this case. And you always have to make sure that the function, and also tell your tests and write it out, that K is never touched, because in the IB syllabus it is very clear that your graph never touches your asymptote. So vertical asymptote is kind of similar. It's basically, to put it into perspective, it's the same thing. However, now you have a line that never touches the y coordinate. So it's also a straight line that is never touched by a graph. And these vertical asymptotes you can most likely see in your graphs as well. Usually in your tests you're given a function, and it's said that where x is 7 to 11, however x is not 9. And so you can always already see your asymptotes right away as well. So for vertical asymptotes it's the same thing. However, vertical asymptotes are usually labeled with H. That's the main difference that you always have to know for this. And also something that is very important in your test papers as well, and something that you have to know throughout your whole course is intersection. So if you have, so intersection, what it means is essentially two graphs going over each other. So to put it into perspective, I can bring out 2x plus 1, 2x plus 1 minus x plus 3. And you can graph, and you can see that they intersect. And if you put second trace, and you go to intersect, and then you first start with one graph, and then you go over it with your second graph. And for this, I recommend you to actually go to your guess, and then you enter, and you get your intersection coordinates, which in this case are x is 0.7, this is rounded, and y is 2, 3 ellipses. And this actually is very important, because I also use intersection to find the x points as well. So if you have your function to be something like x squared minus 3, and you have your x value, if you put one x value as just y is equal to 0, you can very clearly always get your you can always get your roots, and you guess, and you get your answer very clearly. And I always have to also remind you that these are actually very easy examples. However, usually in IB, the difference is that you're not given just 2x plus 1, and you're given something usually a bit more difficult. What this means is that you're given functions that have like to the power of cube, and then you have to find like how it is intersecting with another cubed function. And that's it for me. Thank you.